first webinar was about UX, mainly for business analysts and functional people. Now we're running one on streaming, which is kind of indicated by Kubernetes and Kafka here. And we will have another one later, maybe in a couple of weeks, because we have this one guy who used to be Siebel developer working at Ideaport Riga. Then he started to do some OpenUI development with React. And then he became web developer. He left Ideaport Riga, and now he's coming back. And I really hope that his story would be very interesting as well. And this is the link to main blog post about this Hedging Your Siebel Career series that we're running. There you are able to find all the recordings and the PDF material from the UX sessions. And also there we will publish the recording of this section and PDF slides from today's presentation. So this is like something for you to check if you're interested. Today's presenters, we are two today. So it's myself, Yuri Sterauts. So I know most of you who are kind of joining this webinar. I've been working in Siebel industry for quite some time, maybe 20 years or something. I think so this year is going to be 20. And I'm one of the co-founders of Ideaport Riga, which is a company focusing on CRM solutions. So we started with Siebel. Now we also do Salesforce, and I think we're going to do also HubSpot. And we implement those platforms, but also extend those with the different mobile apps, so with the web applications running on top of Siebel, and obviously integrations. And the Yevgeny, his name here is spelled like as Eugene, more international type of pronunciation. He's Siebel director at Ideaport Riga, so one of three guys who are leading our Siebel capability. And then he will tell more about himself in the couple of minutes. We will start mainly with a high-level overview, like what is the motivation for adopting streaming and how can it be improving stuff that we do. There are plenty of scenarios about the streaming, some about data replications, some other into the data warehouses from different data sources. And we had a webinar on that topic before on Kafka and data streaming and different scenarios for Siebel. As I will be sending you this recording and link to this PDF, I will also include the link to the previous session we had. But this is going to be about more our experience and particular situation when we have Siebel at our company, and then our company starts building digital applications. So be it mobile applications or web applications, they could be customer-facing or employee or partner-facing, all the different scenarios. And since we were in a couple of these projects before already, I think even like 8 years ago, we've been building some claims handling solution with the front end for end customers and for the partners at one of the Russian companies. Then we used Oracle Fusion middleware as an ASB. Then from Siebel side, we would need to expose SOAP services. Of course, now it's more REST, and Oracle is doing a good job improving those. And of course, many companies, instead of using traditional ESB, use API gateways. But this would be pretty much the architecture. So there would be web application, mobile application on top. Through the middle tier or API gateway, they would access Siebel either through SOAP services or REST services. From simplification point of view, because obviously I'm trying to simplify things here. If I would look at commands that the digital apps are sending, basically everything related to creating new records, updating those, or deleting in some cases, it would kind of follow the same pattern as a query where we just need to read data from Siebel. And if you kind of try to compare things, so in such a setup, we have more digital applications are connected and more customers are joining these applications, or more users are joining. Load on Siebel increases, and we don't really like it. Also, we kind of increase dependency of Siebel. So, of course, some of us are pretty much advanced, and we could run Siebel more or less in 24/7 mode. But for many of us, it's not still possible. When we do deployments, we need to take Siebel down. And the more the digital application channels we have connected to Siebel, more service downtime we're taking for business itself. And of course, nobody really likes it. If you look at how fast these digital applications are, the performance of them, I would put here orange as well. So of course, if you are a company with a deep pockets, you could buy Exadata machine and solve all your problems related to performance, load, and stuff like that. Maybe not dependency, but load and performance for sure. For many of us, it's not ideal. The first step, at least we are taking in some of the projects, and this is where Yevgeny is going to show more, is adopting this command query responsibility segregation pattern. And the idea is that if we want to send commands from the digital channel applications to Siebel, we still use the same pattern, so ESB or API gateway and so REST services on the Siebel side. So all the business logic resides in Siebel. If something doesn't go through some of the transactions, then we show the error message or return error message to the digital application, which is calling our service. For queries, we start using streaming. The idea is that we try to separate these digital applications with their own databases and Siebel, and do it in a way that whenever any record or record which is of interest for the digital channel application is updated, we immediately, in the near real-time fashion, push it through the streaming platform, which is Kafka in our case, or like commonly used scenario, into the database, which is controlled by the digital channel application. If they just want to read the data, it's their data store. It is close to the consumer or front end they are building. Kind of they control it. In this way, we decrease load on Siebel because for all the queries operations, we're not as a Siebel anymore responsible to serve them. We decrease dependency. When we are down, this application can still function in the read-only mode and user can see the data. They needed, maybe some functions are not available. Since majority operations usually are queries, digital application performance is rapidly improving. And basically, this is like the story we're going to tell you more in the details when Yevgeny is going to share his journey with you. And then, of course, if you kind of want to take it to full extent, when we want to make this digital channel application fully independent of Siebel, then both for commands and queries, they use on database. We have like streaming platform in between. We also start getting change data commands from Siebel as well. So we start updating the records by reading messages from the streaming platform. In this way, load on Siebel decreases or stays the same as in this CQRS pattern, command query responsibility creation pattern. We kind of remove all the dependency of Siebel, and then digital apps working very well, but at the end of the day, it is their responsibility to optimize their performance. And this is the overall motivation why we want to move from the real-time web services to near real-time streaming, because like with streaming, depending on the platform you're using, but there is obviously a delay from 2 seconds to 15 seconds or something like that, depending on how complex transformations you want to make in between. But this is the general idea. And it's a very simplistic view, but this is to explain why we try to change this integration pattern from web services to streaming. Yevgeny, it's your turn now. So time for your story.
Okay, hello everybody. So my name is Yevgeny. First of all, let's talk about me. So what experience I have and why I'm presenting today about the streaming and about the Siebel. So I have something around 15 years of experience in Siebel. I was participating in many Siebel technical areas, starting from just simple configuration to OpenUI, various integrations, etc., etc. So have quite a lot of experience in Siebel. I also have developed couple of tools and applications inside Siebel to make work with Siebel simpler. And I know that these tools still are used in multiple projects, not only the projects where I was working. One of them is for the reporting. So this tool is called Autodocs. It helps generate reports based on the Siebel data. And all configuration is done inside Siebel. So it's not
it's like BI publisher replacement, right?
Inside Siebel, yes.
Okay.
Yeah, another one is to check quality of configuration in Siebel. So it's like a helper tool for developers.
So basically, there is 56 different queries you are doing against Siebel database to understand how good or bad configuration is and what problems are in scripting and stuff like that. And then it
basically
generates your report in Excel.
Yeah.
Okay.
Yes. Yeah. I know that people are using this tool to check is the quality of configuration good enough.
I think kind of every Siebel integrator has such a tool.
Yeah. Maybe. I just decided to put it here. For the last year, actually more than a year, I'm working as a data streaming specialist and created this platform for data stream from Siebel to cloud, and working on this till this moment. I have some other skills which I gained not from the real projects, but from my pet projects. Basically, that's JavaScript and Java. Also, JavaScript I have used in OpenUI, and I can juggle. That's just a fun fact about me. Okay, so a little bit more about the context, about the client. Client is using Microsoft SQL as a database for Siebel. He also has a subscription on Azure Cloud. And there was a requirement from the client to have as fresh as possible Siebel data in the cloud so that they can use this data in digital apps. They can use it maybe in the full text search, etc., etc. Scenarios can be different. But the main one was actually to use in the applications, not to call Siebel directly, but use data from the cloud. And one of the requirements was to have near real-time data in the cloud, so that we do not do any one-time batch copying from Siebel to cloud. So we want to have it in a streaming fashion.
And this is sort of, to give more context, it's about field service mobile applications, right? Several of them for technicians doing some repairs or inspection in the field.
Yes, exactly. And also a requirement was to have this data in NoSQL database. So it's not just a copy of the Microsoft SQL, it's totally different database technology. So we cannot utilize things like, I don't know, that database replication, etc.
And again, the idea behind this requirement for NoSQL so that we were looking at optimizing speed, how these mobile applications can load the data, and then the schema of the documents is this NoSQL database is more or less optimized for the mobile apps, right, Yevgeny?
Yes, that's correct. Yeah. And the last but not least, solution shouldn't be very expensive and it should be maintainable. A little bit more about the requirement itself. So what does it mean actually, like to have a fresh Siebel data in the cloud? As I said previously, we cannot use batching for this. Like even if you do batching, like, I don't know, like every 5 or 10 minutes, that's still not fast enough. So in that case, in the cloud, we will have like a 10-minute old data. So that's not good for our case. So we cannot utilize things like ATL, like any database replication techniques, any custom solutions that copy data from Siebel to the cloud. It also means that we need to have like a streaming of data. So that means that once data is changed in Siebel, like it's created, it's updated, it's deleted, it should be immediately be reflected in the cloud. So every change should be like streamed one by one, not by portions of the data. That means that we should have a protection from data loss, because if the streaming will be working and something will happen with the streaming, we shouldn't allow like to skip or miss data in that scenario. And the last one also, it's maybe the same what is data loss means, but I want to like emphasize on this, that we should have a reliable mechanism to recover from any like failures that we have. For example, if for any reason streaming stopped to work, we should be able to run it and run from the place where it has stopped, exactly from that place, so that we didn't miss any data. So what solution we can utilize for this?
Can I ask a quick question?
Sure.
So,
Sure.
sorry,
Yeah.
You mentioned fresh data from Siebel, right? What happens to existing data? Are we moving only the new data to cloud, or what's the mechanism you're recommending?
I guess you are talking about like historical data.
Yeah. So
yeah.
I have a Siebel system existing we've been using it for 10, 15 years.
Yeah.
You know, a lot of data there, right?
Yeah, good question. I didn't cover it here in this presentation. I guess that's like a separate maybe topic, but for this, we can actually use any like batching mechanism we want. We can do it like using Azure Data Factory. We can do this using ATL, whatever. So since it's like a one-time job, so we should do it only once. And after that, we will work as like in a streaming fashion.
So we do kind of do this initial load, right?
Yeah. We are for this client.
And then we sort of turn into this streaming mode, if you will. But
okay, so once we do the initial load, and then going forward, any new data would be in a stream.
Exactly.
I know you probably be covering, but I'm curious to know what would be the delays, or how, you know, are the data going to be in sync real time, or those kind of stuff? I'm kind of interested.
You mean how big the delay is?
Yep.
Not more than 5 seconds.
Okay.
Yeah.
And again, it's taking into account that we need to do pretty complex data transformation from Siebel format into this NoSQL document format. For example, if the contact data is updated, but in the collection of the documents, we have more or less, let's say, view from service request point of view, and contact data is just one of the attributes, we have to figure it out in which service request this particular contact is involved and update all of these records. Okay, and this is a bit tricky stuff to do. And you know, we have a solution for that, but we're not covering it within, you know, this document.
Understood. Okay, thank you.
It's also like a question about like how you organize data in the cloud. So you can of course like put everything together and make one big message, or you can maybe separate by multiple small messages and then query this information inside mobile app. Yeah. So what possible solutions we can have here? Since I said that client is using Microsoft SQL, I know that this database has a so-called mechanism that called like transactional replication. Basically, it's doing what is needed for us. So it's replicating like transaction by transaction in most probably like near real time. But with this, we have two problems. The first one is that it works only with like SQL databases, so it can like copy transaction from one SQL to another. We have also one more limitation, is that as far as I know, this mechanism is using primary keys, and Siebel doesn't use primary keys. So all the raw IDs in Siebel, they are just like simple columns. Siebel creates only like unique indexes on that, but it's not a primary key from Microsoft SQL Server perspective. So it's just a normal standard columns. But the transaction replication it requires to have primary keys. Okay, another solution could be a custom one, and it can work on the business logic level. That means, for example, we can implement some kind of trigger mechanism on the business component level, for example, like in runtime events, or maybe in the scripts, maybe somewhere else, like workflow policy. It will be harder, of course, to do it, but still it's possible, yeah. And then push this change data to the cloud using either like web service or maybe some other sophisticated method, like using GMS queues, maybe Kafka as well, maybe something else. But still, the point here is that you are on the business logic level. It has cons, it has pros. So advantage of this is that you don't need to replicate any, for example, calculated fields that you have on the business component. So you can just read it from the business component and push it to the cloud. But disadvantage, at least for me, is that you have to carefully configure every component that you want to monitor. And that will involve every time a change in Siebel. And that means that you have to do something in Siebel, and you will need then to deploy all the things. It's not so flexible. And also you have to make some sophisticated mechanism to avoid any data losses if you want to do it. Because if you capture like a change that some business component has updated, and you, for example, like calling a REST service to push data to cloud, and for some reason this REST service is not working, and you miss this data. So web service wasn't called, data wasn't pushed, and you just missed this change. And you have to implement some kind of queue that will retry several times, like to push the data, et cetera, et cetera. That also like should be somewhere inside the Siebel. Third solution could be on the database level. It works basically with tables, not with business components. And there could be like two options. Either you like doing it yourself. I don't know, you can create triggers on tables, for example. Not the wisest solution, but still possible. You can do triggers on tables, like catch all events and then push data to another database or to the cloud. It will have the same problem as previous solution because you can also like miss data. The second option in this category could be that you can utilize CDC. CDC, if somebody doesn't know, it's change data capture. That's a database technology. I think most of the modern databases have this technology in some form. And basically that's a place where all events are registered by the database itself. And you can read this place and all these events will be listed in correct order. And you can just read all these transactions. And that's exactly what is happening with database. So you can just use this CDC to read all changes and then do something with it, either push it to cloud or, yeah.
Actually, can I ask a question? Yeah, so both the approaches that you mentioned works really well. Actually, in one of the projects, we have used CDC, right? And we have used last updated column, which Siebel provides as a system column to push the data to Kafka, right? But as you said, you are pushing data to NoSQL database, right?
Yes.
And if I consider the entities in CRM, right? If I have to do some analytics on SR, order, account, or anything, right? It's like a parent-child, grandchild entity. Both the solution will not tackle those, right? Because if I have account, then account contact, means intersection table, we have a lot of data, contact address. So have you done anything on that?
Yes, but it's also a question like how you organize data in NoSQL database. So if you want to have, for example, account and all contacts inside one NoSQL message, then of course you need to do something about it. So you need to join all this data together, one account and all his contacts, right? We are doing this, but only in some cases of it. So we are not doing this like for all entities like that. One of the reasons could be, for example, what if one account has thousands of contacts?
Agree. Means the example which I cited might be few, right? But most of the entities that we use in Siebel CRM are like multi-table entity. There are very few entity which is single table entity. That's a challenge, right? Because if you try to give data, say using data streaming to say app or say online channel or any channel, right? You want to show customer profile on apps. It cannot come in from a single entity or single table. So that's the reason for my query.
You're totally right. That's a really good question. I didn't cover this part in the presentation, but maybe that could be another topic.
Yeah, actually, the trick here is that we're kind of simplifying a little bit, and we want to focus this session on how we can learn these new technologies, okay? But if you kind of go into this particular implementation, if I understand it correctly, then, for example, if you take contact record, it's stored in several tables in Siebel, right? And then even though, like, if we want to create one contact record in another database, we still need to combine the data from these several tables as a one record. And again, if we start talking about document collections, which is NoSQL hierarchical structure, then it gets even more complicated because we need to take into account all the relationships we have between different components in Siebel and stuff like that. For us, the solution is that, in fact, we do have some kind of staging database which stores data from Siebel and also the relationship between different objects. And when we get the data from Siebel, it first taking into account this data schema we have defined, it updates this staging table. And then from the staging table, we pull the data giving the format we need to have for this NoSQL database. Because in this NoSQL database, there are also several collections. And Evgeny, correct me if I'm wrong, but the structure is similar to Siebel business objects. So you have like parent business component and many child business components over there. So there is like another component involved, like a staging table, where we resolve this issue that in Siebel we have separate tables, but at the end of the day, we need to produce kind of a hierarchical document. If you're kind of interested, we can go more deeper into this discussion. Ashish, happy to spend more time.
I got it. Means the idea was to understand how you guys have done it. Right.
Yeah, because this is definitely one of the challenge with this CDC, right? So that you are working on the table levels, and Siebel is much more sophisticated than that. But of course, even as Evgeny mentioned, if we have some calculated fields, we don't have this data in database, right? So we have like nothing to push towards the cloud. So we have to replicate calculations elsewhere. But these are, you understand the challenge. And thank you.
Yeah, thanks for the question. I guess you have already understood that we decided to use a CDC and to work on the database level. We have found an open source tool that can work with CDC really well. That's called Debezium. So basically, it's like polling CDC every, I don't remember, 2-3 seconds, something like this, and just reads all the data that was generated in Siebel database. And the really good thing about Debezium is that it integrates really well with Kafka. So that was another tool that we have decided to use. So we use Kafka as a message broker, and Debezium integrates with this Kafka. And what we get using Debezium plus Kafka is that using only two tools, we are basically covered the first part of the streaming. So these two tools are fetching data from Siebel and automatically pushing data to Kafka. And what that means is that in Kafka, we will have one topic per table, and these topics will be enriched with data from Siebel. Once data in Siebel is changed, like deleted, inserted, or updated, we will immediately get a message in Kafka for this table in its own topic about the event. Like if it's a deletion, we will get a message that data was deleted. So record with this row ID was deleted. If data was inserted or updated, we will get a message with data.
Yeah, and I would add that Debezium as open source, I think they have some kind of relation to Apache Foundation, which is also running Kafka. So they are, I think, kind of sponsoring it. So they work really close. And the second topic that in Debezium, you can also mask data and filter them and do some other, maybe join and stuff, right? Evgeny?
No, it's not possible to join data, but yeah, it's possible to mask data if you want to secure some sensitive information. Maybe let's talk a little bit more about the Kafka, because there exists a lot of different versions of Kafka. So there is just raw Apache Kafka that you can use, and you can install it by yourself. You can configure it, but it's too much. So it involves a lot of work. Also, there is enterprise versions of Kafka, like Confluent. So you can buy Kafka version from the Confluent, and basically all the configuration will be done for you, and you will get also enterprise support for Kafka. So if something will not be working in Kafka, you can create a support ticket to Confluent and they will help you.
It kind of works in two ways with Confluent. So on one hand, they have Confluent platform, which is sort of run by you. So it has this enterprise support. It have plenty of different connectors, including commercial ones, CDC, which work fine with the Oracle database and SQL database, DB2, whatever you have. And also they have Confluent Cloud, which is their hosted environment. And a couple of months ago, they also announced Confluent Cloud at Azure. So you can leverage your Azure subscription and basically get this Confluent Cloud as a service from Azure as well, which obviously simplifies the maintenance and stuff. But it was not the path we took, right, Evgeny?
Of course. So we decided to use free version of Kafka, but not the raw one that provided by Apache, but it's called Streamzy. It's a special distribution of Kafka. It's free, open source, and I will describe a little bit later why we choose Streamzy.
Okay, because you have to remember that solutions shouldn't be expensive, right? So I mean, if the company adopts Kafka on the wide scale, and we have companies which run Kafka and it connects tons of different applications, that's one story. But if you are in this position, of course, you wouldn't choose to run naked Kafka yourself and maintain Kafka on your own. So you'd have a team, or at least DevOps team, who would tell you which topics you need to create, and then you would be responsible for pushing the data into Kafka and consuming them if you want to. But for us, it was sort of extension of Siebel project and Siebel ecosystem, and we didn't have enough authority to go and say, hey, why don't we buy this perfect Confluent platform just to power up our mobile applications?
Yeah, and maybe also another point is that we don't need actually all the tools provided by Confluent. So we are using Kafka just like a transport to push messages and to read them. That's it.
Yeah, because if you want to do some streaming analytics on top of that, it's kind of really cool thing. And if you start adopting Kafka as a database mentality, then it's somewhat different, but it's not what we needed. So we just needed to have a reliable message broker, which works really fast, which scales nicely, and pushes the data through really quickly.
The next question that has quickly arisen, so where actually we need to host all these tools and solution? So we can run it, of course, on some dedicated on-premise server, but that means that we need to maintain it. Not very good. Maybe we need to run it as close as possible to Siebel or even database, since we working with database. Or maybe we need to create a virtual machine in the cloud and install Kafka and Debezium and all other tools there. No, actually the answer is Kubernetes. Thanks. So Kubernetes has several benefits. So first of all, it's quite easy to scale computational resources. So if you need to add more power, more CPU, or more memory, or more machines to your infrastructure, it's just like as easy as click on the button. Also, it can be run on any hardware. So you can run it even on your premises, or you can run it in any cloud. In our case, it was Azure. Azure has AKS, that's Azure Kubernetes Cluster. It's also very easy to set up in the Azure a new Kubernetes cluster, just a couple of clicks and you have a new Kubernetes and you can work with it and install all the applications there. The last one is that you basically forget about the infrastructure at all. So you don't need to worry, will it be working, we would have enough memory, CPU, etc., etc. So about any like problems with hardware, things like that. Everything is virtual, it's running somewhere. And the best thing is that, for example, even if you like decided to use Azure for the Kubernetes and you have configured your application for Azure, even if you in the future decide to stick with some other cloud or maybe to move to on-premise, then you can just take this configuration to be working in that new platform without too much modifications. The last point, which is not listed here, is actually because of the streams that we decided to use. So basically Streamzy, that's a special version of Kafka that is suited for Kubernetes. So it provides like a package that you can deploy to Kubernetes and it will automatically like deploy Kafka in your Kubernetes just using a couple of commands.
So in your setup, Evgeny, you have Kubernetes, right? So you have these Debezium pods or services running there. You have this Streamzy Kafka running there, and also this staging environment as well.
Staging environment, it's not in the Kubernetes, it's in the cloud, but since it's database, it's just database in the cloud.
Okay, but then, the thing which is pulling from the staging tables and loads in this Cosmos DB, it is as a service also running in Kubernetes, right?
Oh,
so
yeah,
these
yeah.
processors.
Yeah. So transformation logic, it's running inside the Kubernetes. Yeah, so we have a plan how to implement that. Now let's do it. And few months later, I have found myself that basically I need to learn all these things that are listed here. It's 10 of them, and it's only like the, I would say, crucial things that I need to learn. I'm not even speaking about the minor like tools and minor libraries and all the concepts and all the recommendations that I need to follow like to implement this streaming solution. Yeah.
Do you want to go one by one, or what all these icons mean, or how?
I can, yeah, I can, of course. So starting from the black one on the top, yeah, this one, that's a Kafka. So I don't know.
Well, let's test Evgeny. So if you learning all this, so you have to know what this icon means. Okay, so let's do it like this. Okay.
This one is basically Kubernetes, so that's our hosting platform. That's a key called Customize, and that's a tool for Kubernetes to simplify deployments to Kubernetes.
Okay, yeah, Helm. Mm-hmm.
Helm maybe looks like Customize. It also like helps to deploy things to Kubernetes, but in another way.
Okay.
It's
hard
to
explain.
Like
native sort of Kubernetes tool, right? But it's not that advanced as Customize, right?
No, I wouldn't call them native,
okay.
But I would say that it's a default tool if you want to install something in Kubernetes.
All right.
Yeah, the next
I don't know
one
this one. So what is this one?
It's Streamzy.
It's Streamzy. Okay, good.
Yeah, it's a special version of Kafka.
This is like something from Azure. Let me guess. So.
Yes, yeah, correct. That's a Cosmos DB.
Cosmos DB. Okay, this is something burning here. This is how you felt, right? So.
No. that's Prometheus. That's actually fire from the Olymp, or
okay.
Is that the one? Yeah, I guess. Yeah, Prometheus is how to explain that? That's a server for the metrics. So if you want to have a monitoring inside Kubernetes, you should most probably choose Prometheus.
Mm-hmm.
That's the place where you will store all your monitoring and metrics values. Next one is Debezium.
Okay.
Yeah, and after that, it's Azure DevOps. So we're using Azure DevOps to simplify deployment of the streaming. Mm-hmm. So for example, if in one release we have added new table or new column or whatever, or new transformation, then we will just run this DevOps tool, and it will deploy all new stuff to the next environment and eventually to production. Yeah, and the last one, the orange one, is Grafana. That's basically UI for Prometheus to show all the monitoring and all the metrics data. Yeah, and I just wanted to mention here that before like doing streaming, I didn't even know about like of existence, at least of half of these tools. So, of some of them, of course, I heard something, but never touched them myself. So basically, I have to learn all this stuff from the scratch by my own.
And have you tried the Oracle OCI?
Sorry, which one? Oracle?
Try the Oracle OCI that has all of these.
Oracle OCI.
Yeah.
No, I mean, this customer is Azure centric, so and that's why we didn't consider Oracle OCI.
Okay.
Yeah.
Okay.
Yeah. In the next slide, basically all. Sorry, somebody should.
Okay, go ahead.
Thanks. Yeah. So this slide is actually like describes all the stuff that I have already told about every tool. I think we can go on. Yeah. Yeah. So how did I survive like with all these tools? So first of all, and big thanks to client is that I was like working for this client for many years, and I gained a lot of trust from the client. And at some point, they decided that I can do that. I can implement that requirement, and again, a lot of trust from them. And mostly because of that, I was able like to learn all this stuff, to implement all this stuff, and it's still like working. That's really good. Of course, also I have some links to documentations because another point is that all the tools that I was using has a really good documentation, really good. The Visium, Kafka, Streamzy, Azure, all these instruments, they have a really good, really nice documentation. Almost all my question was resolved going to these resources. Of course, it wasn't without any Googling and research and many trials and errors, especially with monitoring, because monitoring is a totally different world. It's a big one, and actually, if you want to monitor such complex solution as a streaming, you need to first of all, you need to figure out what exactly you want to monitor and measure. And another topic is how to configure that and represent that, and I don't know, maybe create an alerts using that, etc., etc. So many questions and a lot of stuff new to me.
And what was your kind of largest error, Evgeny? Like, what you have learned?
I wouldn't call it my error alone.
Okay.
So it was combination of maybe my lack of knowledge. But the problem was, for example, is so that Azure has this thing called analytic workspace, analytic log workspace. So that's basically a database also for metrics and monitoring. So you can push metrics data into the Azure, these Azure workspaces, and then you can use it to, for example, to send alerts if something is going wrong in the streaming. But the problem was that I was pushing all metrics that are produced by the streaming by the applications running inside Kubernetes. And since I wasn't, I didn't have access to the cost page, so I didn't know how much exactly this solution costs. Or, I mean, this workspace solution costs. I didn't know how much we are basically client pays for this. And at some point, I have found out that actually the price just for the monitoring was actually the same as for the streaming. So, and we basically have to reduce all the metrics to only a couple of them.
Okay, so basically, with the cloud, so it's kind of very easy to get started and just with a couple of clicks to get it running. But then you have to be conscious of how much actually it's gonna cost you, right?
Yes.
Yep. All right.
Yeah. So this slide is it's a very high level. So that's our solution overview. So all the questions that you had about the transformation, it's covered in the 6th circle. So
I think we need to add this green box over there because it's obviously does a lot. But again, it was not the point of this session, maybe.
Yeah, actually, this picture was much bigger, so I decided to make it smaller, not to cover a lot of details for this.
Okay.
But in a nutshell, it works so that we have a database, then we have a Dependency that listens CDC, and it pushes all data to each topic for every table. in Kafka. And then we have some magic box under number 6, which puts all this data together and push it to the Cosmos.
And what is going to connect to Cosmos? It's API, it's apps, user interfaces.
How do we
Yeah,
connect?
it's a mobile application. Several mobile applications which are talking to Cosmos DB. Yes.
Yeah. Okay. Yeah. This is what I was guessing. Yeah.
Yeah. All right.
So basically, that's my story. How I was working as a Siebel developer, and at some point, I had the requirement to make a Siebel data streaming to cloud. And this was my basically journey to learn all this stuff to make it work, to make it happen.
All right. I think if we have questions, it's right time, or maybe like I will just finish with a few other things, because and then we can go to questions. First, I mean, for those of you who were in Virtual Siebel Summit back in September, Oracle also announced this Siebel event-driven framework. Basically, the idea is that they would have this native publish subscribe messaging targeted for Kafka. And it means that from Siebel, either declaratively or through the scripting, you can put messages into the Kafka topics and then read them. Because again, it means that from our solution, we wouldn't really need any CDC on the database level. We wouldn't need to have any Debezium. So it would be sort of direct connection from Siebel business layer to topics. And I believe this is like really a huge thing that could simplify the streaming itself. And also it will work kind of another way around. So if we have data coming from another systems and we want to read them into Siebel, then instead of using some kind of REST connector, which reads data from Kafka topic and then call REST service, we could subscribe to this topic and do necessary work just within the Siebel. So it kind of simplifies the cooperation with Kafka a lot. Again, this is the link to the video recording, and there was like 10 minutes where our colleagues from Oracle were explaining this framework and also had some pretty cool demos. But again, I don't really know where they are with this, because my expectation was that it's going to be released like really soon. After talking to some of the engineers at Oracle, but now maybe it is dependent on this Oracle Siebel cloud native architecture, like Siebel running in Kubernetes, and again, how fast they will make it available for other Siebel customers. It's a big question. Probably those who are running OCI get it first, but for most of our clients, this is not a solution really. And again, if you are into this Kafka streaming, so please visit Oracle Virtual Customer Advisory Boards. Again, there is like a LinkedIn group for that as well. And if we kind of together push Oracle a little bit that, hey guys, streaming is a big thing, and this is the way how we want to integrate Siebel with other applications, and could you sort of prioritize this release or kind of make this event-driven framework available before any cloud native stuff, because it's technically not really related or kind of fits together. I think we can get it out really soon, or really much faster than if we wouldn't do anything, because obviously it kind of simplifies all this streaming from Siebel to Siebel, in the big way, and maybe our solution would be much simpler, and Yevgeny wouldn't need to learn half of the things he had to learn right now. Maybe like 30% he wouldn't need to learn. Okay, and again, these are kind of resources that Yevgeny put together, which kind of really good one. For myself, I follow this guy who is kind of working at ConsoleLand, but so he's like evangelist, and he's publishing a lot of use cases. He's doing all these comparisons, like 5 different ways how you can deploy Kafka, how Kafka stands against ESBs, and should we get rid of ESBs and have just one Kafka streaming platform and stuff like that. So if you are into the Kafka that Kai, this German guy, like is the one to follow, if you are interested in running kind of similar workshop, we can arrange it. It says here for the end customers, but we can talk to any of you, also the integrators. And also what we are thinking internally, once we have some capacity available, I'm not hoping for Yevgeny, but for the other kind of technical guys that we have, we were also thinking to build a blueprint solution, put it somewhere in the GitHub, but basically it would have the Streamzy version of Kafka in it. It would have some Debezium components which could read data from Siebel, and then they would replicate it to Salesforce, for example. Because at some of our customers, we see the need when they run 2 CRMs, and this bidirectional customer data synchronization could be sort of a cool one. So we might build as a part of this blueprint only like contact synchronization or customer data or account data synchronization. So if you're kind of interested to discuss it or you're willing to get it, you can kind of reach out to me. Now, if you have some questions, let's have a little discussion here.
Thank you, Riz and Anjay for a good presentation. I do have one quick question. Do we have to be in a certain version of Siebel in order to leverage this streaming? For example, we are in, I think, 2016 version, something like that. But I don't know if we need to upgrade Siebel in order to even do any, these kind of, either streaming or anything like that.
It's like if you're looking to push data from Siebel, then again, the solution we have chosen, and we kind of believe that this is kind of could be an optimal solution in many cases, that you use CDC, right? Change data capture.
Yeah,
and
but
basically, usually your database management system would have this option, and it doesn't really depend on what kind of Siebel version you're running.
Okay, I think we have Oracle actually as a database.
Okay, so with Oracle, it's a bit tricky because like from the open source perspective, like this Debezium open source, I think kind of they released recently the CDC connector for Oracle databases. But again, there are commercial ones available from ConsoleLand. You can use kind of Golden Gate from Oracle, but there are other CDC type of the solution which can, using this log miner functionality of the Oracle databases, do this change data capture for you and then put it into the Kafka or something. So again, we have chosen the Debezium. It's a pretty mature solution when it comes to Microsoft SQL database. With Oracle, it's a kind of fresh one. So you would have to look at the options. And again, depending on the kind of support requirements you have in your organization, what CDC solution to use. But if you kind of go for CDC, it doesn't really matter what kind of Siebel version you're running.
Okay, got it. So, but I just want to make, I don't know whether, I'm not sure whether what version of the Oracle we have. We probably have some 11G or something like that.
I mean, CDC is not like new technology, so it has been there for ages. So I'm pretty sure that your version of Oracle will support it.
Okay, got it. So yeah, so we could find some either commercial tool or open source tool to capture the changes and stream it to.
Exactly, yeah. And again, when it comes to reading the data into Siebel, so we have this other customer where we actually read data from Kafka topics, and we need to push them to Siebel. So we created Siebel REST services. Then from the Kafka platform, they are using some of the kind of REST connectors, which basically are capable of reading the messages from the Kafka topic and then calling, the REST service. And this is how it works. And then again, I think if you kind of talk about IP16, then you have basic version of Siebel REST services. And again, if it's not enough for you, then obviously you need to upgrade, because kind of one area where Oracle really invests into Siebel is this REST service enhancements. So
yeah, I think from 2017 onwards, right?
Okay.
Yeah, I believe it's 2017 onwards. We have a better version, but 2016, I'm not sure whether it's capable of handling all the the SOAP requests. But yeah, okay, thanks for the information.
Yeah, sure, Raj. Thank you once again for joining this session and for your time. And then again, we will be sending materials pretty soon. And again, please reach out to me if you want to have another session like that, but for your company only, or if you would be interested in this sort of blueprint streaming solution based on Siebel CDC and Streamzy Kafka working in Kubernetes. So we will be working on that as well. So kind of reach out to me, and we will send you the copy of it when we have it done, maybe by the middle of the summer. Thank you,
Thank you,
Evgeny, for sharing your story.
Yeah, thanks,
exciting.
Iris.
We didn't do a lot of demonstrations, unfortunately, and also the previous webinars on Kafka and Kubernetes and how Oracle is moving into this cloud-native architecture. I will be sending the links to those as well as I send these recordings. Thank you very much, and stay healthy, and let's keep in touch. Bye-bye.